I got 25 minutes. This will either take 25 or 15. I don't really know. Whenever I do run-throughs, well, they're all over the place. So my name is Sean T. Allen. If you do tweet anything about me, please put the T in there. I've been using it for a long time now. Years ago, when you'd Google my name, the first hit you get was a guy who was arrested for selling meth in North Carolina. So I'm trying to keep the T in there for professional purposes, although eventually I'm sure somebody's going to screw that up for me. You can find me on Twitter in those places. If you follow me on Twitter, just be aware ahead of time. There'll be a little bit of computers, an awful lot of music, and probably a lot of cursing. So this talk today is about scaling, but that's a really broad topic, and I got about 24 minutes left now in order to get, so let's narrow that down some. Scaling is really about reacting to change. Also, this is really unfortunate the way it's going off the side. I guess the aspect ratio isn't actually correct on that. Anyway, so when we talk about scaling and reacting to change, right? I mean, we could be talking about an awful lot of things. We could be talking about scaling engineering teams and change that happens there. We could be talking about scaling applications, and in particular today, I am going to be talking about scaling applications, but also in particular, I'm going to be talking about reacting to changes in data, because that's really what I care about. But it's a narrow definition. It's a narrower definition, but it's still not particularly narrow. So let's take that down a little bit more and say, we're going to talk about changes in application state, right? That's generally a lot better. You know, application state being, there is some data that our application accumulates over time, and it needs to know about what came beforehand in order to make a decision about what it's going to do now based on new output, right? So that's still a little broad, so let's narrow this down to a really specific thing, right? I want to talk today about scaling as it relates to handling more things, right? We're going to have more things. Okay, so I was going to be specific. That's probably not particularly specific. So I'm talking about, like, your application is built and you're going to have more customers as you go on over the course of time, right? You start with one customer, you're going to have, I don't know, you're going to be really successful. 1 million customers like 3 weeks from now, right? And the amount of data that each customer actually takes, you know, probably not going to change all that much. The size of their record isn't going to get that much different, but there's going to be a lot more of them, and there'll be a lot more orders. There'll be a lot more vendors too, like just all of it, just a lot more things, right? Just so many more things. And you know, that's the type of scaling, you know, that I want to talk about today, right? And there's a name for that type of scaling. It's called horizontal scaling, right? And in general, when we're talking about scaling, there's two different descriptions for what scaling is. There's horizontal scaling and there's vertical scaling. How many people are familiar with what vertical scaling is? Okay, all right, so vertical scaling is basically when you're like, hey, I'm running this thing on one box, and I'm going to keep running this thing on one box, but there's something here which is a resource which I'm constrained on, and I need more of that, right? So I started with 4 gigs of memory. My application needs 8 gigs of memory now. I need to upgrade, you know, the memory on my computer. Or I need more CPU. I started with 2 CPUs in this computer. I now need to add 4, right? Or move to a bigger EC2 instance. You know, that would be vertical scaling. We're taking this up. We're not adding more machines, right? We're just adding more something on a particular machine in order to make it happen. And frankly, if you need to do scaling, hopefully you can do vertical scaling, because it's way easier than horizontal scaling. Horizontal scaling means I need to add more computers, basically, right? And when you're adding more computers, this means you have a distributed system. How many people have ever tried to actually write like a distributed system or have run one? Okay, so these are the people who understand the pain. Everybody else, you generally want to avoid doing this if you can, right? But if you're going to, there's a paper that I strongly recommend that you read. It's called Life Beyond Distributed Transactions. It would say transactions off the end there, but the aspect ratio, again, they said 16:9 would work, but whatever. And so this paper was written by Pat Helland. There was 2 versions of it. The first one came out in 2007. The second one came out in 2013. And I love this paper. I go around talking about it all the time. I gave a talk on it that was like 45 minutes long called Pat Helland and Me at VelocityConf earlier this week. And one of the things I love about this paper is that it's an engineering paper. I don't know how many people in here like to read papers. I'm a regular person at Papers We Love in New York, so you know, it's awesome. Yes, you, I see you, I saw the head nod. Good, another paper lover right there. So an awful lot of papers that you read can be prescriptive. They're going to tell you how to do a thing and exactly how you need to do it. And these are really good when you're talking about like data structures, for example, right? But this paper it's more of an engineering paper. It's like, hey, here's an architectural idea on how you can go about building for a specific use case, right? And within the paper, Pat has like a few big ideas, okay? And of these big ideas, well, I normally talk about 2 of them, but that normally takes me about 45 minutes. So we're just gonna talk about one today, all right? Just one of those big ideas. And that idea is this thing called a 2-layer architecture. It's a big part of the paper, and it's an idea that I've really come to love. And so what it's basically saying is we want to divide our applications into 2 different layers in order to be able to do this horizontal scaling of things, right? And to make this easier. So the first layer, and this is the layer that as an application developer you would generally interact with, it's a layer, it's a scale-independent layer, right? And in the scale-independent layer, this is where our business logic is gonna live, right? This is where, like, say, if I do a lot of stuff in the big data space, so I get to talk about counting words an awful lot, because word count applications are just the thing you do. It's sort of like Hello World, except, well, I don't know, probably even less interesting than Hello World. But, so, if I was going to write a scale-independent word count, then all of the code which implements my business logic of taking some text and splitting it into separate words and then counting those words, that would live in my scale-independent layer. And then I would have a scale-aware layer. And the scale-aware layer is the level where this is where everything, in order to do the horizontal scaling, is going to live, right? You could call this a framework layer, although lots of people really hate the word framework. And if you say framework, they immediately start to get this idea of some awful thing they were subjected to once. You could call it a platform layer, but that tends to give even more people like heebie-jeebies, you know? So you could also just call it perhaps a super useful library layer. It doesn't really matter, right? But it's there to provide you a whole bunch of services. In the same way of like when you're writing a Python program, you know, there's a platform upon which this is built. You're not worrying about memory management, right? Because the Python runtime goes ahead and takes care of it for you. So this scale-aware layer, right? It's going to provide you some things that you need in order to write your scale-independent business logic. It's going to do things like provide you some means of doing clustering, right? Because if we're saying we're going to scale horizontally, this means that we need to have a bunch of things that are working together across different machines in order to accomplish our task. In order to do that, they have to be able to work together. We call that clustering, right? A bunch of things working together for some reason. Then there's going to be data that needs to fly around between all of them, right? So we need some way to make sure that these messages, this data, gets to wherever it needs to go and isn't sent to the wrong place, right? Got that. Then, well, doesn't even get the whole word. Guaranteed message delivery. We need to make sure that these messages actually get there, that they're delivered, and that they're processed in some fashion. And this may not sound like much, but this is actually one of the hardest problems in distributed systems right here, is to make sure that not only does your message get there and that it's processed, but then when you have a failure, that you don't reprocess the thing over and over and over again. I can tell you this, I once worked for a company where we built inside of Apache Storm, which helps you do some things like this, we built a system that sent emails to clients, and we had a failure, and it features, Apache Storm features this thing called at least once message delivery, which means it guarantees that every message will arrive at least once. It also means, for example, that if you hooked up an email system to this, that some of your clients in a failure scenario might get that message, say, 350,000 times, for example, which is a thing that I accidentally subjected some people to. So, The last thing we want to get here from this as well is fault tolerance, right? We need some means of guaranteeing that, like, when there's a failure, that our messages are actually going to be delivered, or that whatever the data is that we're keeping in there, or our state that we're accumulating over the course of time, that it actually is handled in some fashion so we can bring ourselves back and we don't lose anything. And all of these are fairly difficult things to do, and we want to make sure that we have these in our system. And then, for that, we need an API to connect these two things, right? I need to actually write something in my scale-independent code which is going to allow it to run in the scale-aware layer. And this is what the company that I work at has built. We're called Wallaroo Labs. And what I want to do is I want to show you an actual implementation of what something like this would look like, just one small section of what code using Wallaroo would look like, because it's nice to, talk about this as a theoretical idea, but it's another thing entirely to actually also see it. So really quickly, Wallaroo, it's a system for doing scale-independent computing with Python, right? In particular, it's a stateful data processing engine. Like, this is one where you take in a bunch of data, perhaps from message queues, perhaps from TCP, and you want to do something like enriching profiles. Say maybe take, you got customer data coming in from one place and actions that the person was doing in some other place, and you build up a profile over the course of time, and when it's like, oh, hey, look, this person has visited these 5 pages on our site, maybe you trigger some sort of thing like, hey, let's give them an offer, because, like, they're a great customer. Or, just some sort of general data aggregation. You could maybe be doing sentiment analysis. Twitter trending topics is an example of a system like this, right? And the important part of this for what we're doing is it's stateful, which means this is for applications which have to remember what came beforehand. And we have the scale-independent API like it, right? And the scale-independent API for this type of application that we'd be doing, right? It's really around a few ideas, which is we want to be able to show what is the flow of data through our particular application, right? Where does it start? Where does it end? What are the transformations that need to happen on this data? In the case of word count, for example, right, those transformations are, we're going to split this stuff up into a bunch of words, and the next transformation is that we're actually going to start counting these words and aggregating on them. And then, yeah, we're going to have that. So we got that accumulation of state there for the counting of the words, right? So this, where it's running off the edge a little, this is a usage of the API inside of Wallaroo that would describe this as a scale-independent application, right? And this is actually, what this is doing is we have 2 separate data pipelines here, which are going to be working together, right? So we got this one pipeline over here, which is taking in some orders. In this particular case, it's market data. Finance folks might understand that one. Sorry, that's actually orders, customer orders. And then we also have market data, right? So we have these 2 separate data pipelines, which we're describing. And yeah, we got some source of data for each one. We're saying, hey, this is where our data comes in. This is the beginning of our pipeline, right? Then we're defining our operations here. Oftentimes we could have multiple operations that are chained together, like word count would have 2 of them. But in this particular case, for this application, there's just one. There's just one operation for each one of them, right? If we look at this here, what this is actually doing here, not that it particularly matters all that much, but it's got this little thing there called check order, and it's going to be running check order against this symbol data. And this is what this application would actually do if I was going to show all the rest of the code today, is that it's keeping track of what's happening with various stock symbols in the market and looking for anything weird that might happen, and then issuing like withdrawals on people's orders to like cancel them if that happens, right? And then, we can also do stuff. We do the same thing down here, et cetera. And we have some sort of sync where data is going to leave the system. So in this case, one of the pipelines, the data is leaving, going out over TCP, and the other one is just updating state in memory, and there's no output at all, right? And with this code, I'm not trying to really get you to understand like how to write a Wallaroo application or anything. I just want to show this to you to emphasize that that when we look at this, there's nothing about, anything about like machines that this might be running on or anything like that, right? It doesn't say anything about like, hey, this is running on 5 machines, this is running on 10 machines or anything, right? This is 100% scale independent code. This could run on one Python process, right? It could run on any number of Python processes, and in this particular case, you know, when we built this system, you know, we were really happy, you know, the first time that we took one of these applications and we'd been running on our laptop on one Python process, and then we're like, hey, let's go put this out there in AWS and run it with 20 Python processes working together. We did it. And it runs, and there's no code changes that have to happen at all, right? And that is really like, that is what I love about this idea of scale independence, of having an API in order to do all of this, right? Yeah, it's just like, this is an idea that I hopefully will see spread to more places of being able to build your application. You can do this because this is so incredibly powerful. I was at my previous job. We had an application which was apparently ridiculously important to the business. It was so incredibly important that it's one of those applications where when I took over the platform team that nobody told me that it existed. But it had been running so well for years that nobody even thought to mention it anymore until the day that it stopped running, right? And it stopped running because it turned out it reached this point that a lot of data processing applications do where it's just continuing to work well, it works fine. And then one day it crosses some little line. It's not a dramatic line in terms of the amount of data or anything that comes in, but it just falls over. And in this particular case, when we figured out where this thing was that we were getting yelled at by the CEO that it wasn't working, we went in and looked at it, and it's being run as one JVM process, right? And it was spending all of its time garbage collecting. And the stuff that it was actually working on, there were only a couple thousand more of those things than they were the preceding day. But it was enough that it had crossed the line where this thing could no longer process it. And unfortunately, you know, it took us 2 months to fix the problem. And it took us 2 months to fix the problem because at that point we had to break this code up and turn it into something that was able to run on more than one process. It had reached the point where we couldn't vertically scale it anymore. The reason why we couldn't vertically scale it anymore is we crossed a little magic line in terms of garbage collection, where way too much of the time in the JVM, which features stop the world garbage collection, was actually being spent doing garbage collection. It had crossed over a line where we were spending far more time doing garbage collection than we were doing real work. And each incremental bit of work just added to that. And we had to rewrite the entire thing and get it so that we could now run it in a horizontal fashion. And the worst part of that was that when we rewrote it, it took us 2 months to get it out there because we kept introducing bugs into it over and over again, subtle little ones. And that was the point when I started looking around and was like, there's got to be a better way to do it. That's when I first came across Pat's paper. That's when I really got interested in the idea. So hopefully from this, some of you folks might be interested in it. Go out, check out the paper, etc. I'm getting closest to being out of time. I thought it was going to be about 90 seconds further along when I got to this point. But just quickly, a few more features of Wallaroo, because I also hope that some people here go check out Wallaroo in addition to checking out the ideas. In Wallaroo, all those computations and everything you do, they're defined with plain old Python functions. There's a couple little decorators you have to put on things, but otherwise it's really cool. All of the state that you'd be accumulating, it's just regular Python data objects. And you can use any Python library, right, in order to make this stuff work. You can use NumPy, you can use scikit, whatever it might be. You can bundle them all inside of a Wallaroo application and go. Yeah, and that's really it. This GitHub repo here, there's a lot more there. There's a link to there's a link to a GitHub repo for the 45-minute version of this called Pat Helland and Me that I've done 3 or 4 different versions of, so you can learn more about that. There's links to both of Pat Helland's papers. You can find my Twitter account there. You can also find lots more stuff if you want to learn about Wallaroo and everything else. Yeah, that's probably pretty much about it. Oh, the one thing that I always do forget is we have a really awesome logo. He's very, very cute. So after the talk, if you want some really cool stickers, if you're into like cute little animal stickers, I had to pull a lot of strings and basically like almost cheat when we were naming like our product in order to make sure that I got cute animal stickers. So please do come get some cute animal stickers from me. I think I got like 5 minutes for questions. Yeah, told you I wasn't going to go over. Made sure on that. All right, so yeah, if you have any questions, fire away. Or not. Stickers then. If you want stickers. Yes. Come get some stickers.
Thank you.
You're welcome.